In this example, we're throwing a ball through the air. The height of the ball can be modeled by this equation right here, which is of course going to be a parabola because of course a ball will go up and then come back down, forming a parabola. Our first question asks us to find out what's the time when the ball will hit the ground. Well, in other words, we just want the height to be 0. So I'm going to plug in 0 for the height of this and then finish writing out my equation, 96t minus t squared. We've done problems like this before. They simply want me to solve this, and I can do that in a number of ways. I could try factoring it, or a lot of people will use quadratic formula. If you have the program on your calculator, I would recommend that you use that. Just be careful when you find out what a, b, and c are in this case. A is the coefficient of x squared, or t squared in this case. B is 96, and then there is no c value, so c is just 0. When you do this, you find you actually get 2 times. There's a time of 0 when the problem starts. So maybe the ball's not thrown, but it's starting from the ground, so maybe you're kicking it. And then you also find a value of 6. So the ball will land back on the ground at 6 seconds. It'll be in the air for a total of 6 seconds. So we've done stuff like that before, but here's the more interesting question. What times is the ball more than 128 feet above the ground? So there's probably going to be a range of values because in this sketch we drew up here, suppose that is where sort of the path of the ball. Maybe that line, this line represents 128 feet. So at some point right here, it gets to be above 128 feet, and then at some point it gets back underneath 128 feet. And the question is, what are those times? So here's what they're asking us to do. Once again, the equation that represents the path of the ball is 96t minus 16t squared. I want to know when that's greater than, more than, 128 feet above the ground. So here's the inequality I want to solve. Well, if you watched the last video, you know the trick is, or the first thing we'll need to do is, set it not equal to 0, but get everything moved to one side. So I don't want to rewrite the order of everything, just because I'm feeling lazy right now, but I'm going to subtract the 128, and now I have to say, when is this greater than 0? Okay? If you want to rearrange it and make it in descending order, that's fine. Otherwise, just be, again, really careful if you're using the quadratic formula, which is what I'd recommend, even though this one does factor. A is negative 16, because that's the coefficient of your squared term. B is, again, 96. This time we do have a c value, it's negative 128. When you do the quadratic formula, or if you do factor this, turns out that there's 2 times. There's t is equal to 2, and there's t is equal to 4. In other words, those are the 2 times when the ball is exactly 128 feet above the ground. Well, as we did in the last problem, let's make a number line to try to visualize what's going on in this problem to finish it. So I'm going to put 2 and 4 on my number line. I'm going to use an open circle because I cannot be equal. I just want to be when am I greater than 0. And then it helps me to visualize the parabola to see what this is going to look like for what interval I'm going to shade. Well, this time, unlike in the last video, we have a negative a value. So my parabola is an upside down opening parabola, which again makes sense. If you're throwing a ball through the air, it's going to go up and come back down. This time, I want to find out when is my parabola greater than 0. So in this case, I want to know when is the parabola above the x-axis. Well, again, if you watched the last video, I talked about kind of standing at different intervals and determining where your parabola is. If I were to stand out here past one of my x-intercepts and look for the parabola, that's supposed to be me, the parabola is located below me. I don't want that. I want to know when the parabola is above the x-axis. Similarly, if I stood at the other end, and looked for the parabola would be located below me. I don't want that. However, if I were to stand in the middle here, in between the 2 x-intercepts, and look for the parabola, there's where the parabola is located above me. So the section I want to shade is this section in between the problem. So really what I found out makes sense. Like we said, the ball's going to go up. At 2 seconds then, we're above 128 feet. We're above there for a while. But then at 4 seconds, we drop below the 128 feet mark. So maybe even for this problem, a number line isn't even the best way to answer it. Maybe I just want to write a quick sentence that when's the ball going to be above 128 feet? Well, between 2 seconds and 4 seconds. Anything before then or after then, the ball will be under 128 feet.